Hello, this is Dongyeong Hwang. Today, I will present our paper named FlowerFormer Empowering Neural Architecture Encoding using a Flow-Aware Graph Transformer. Let me begin. I will start with an introduction. Deep learning models have proven their effectiveness across various fields. Additionally, a vast number of deep learning architectures are still being researched and developed today. What could be the reason for the emergence of so many architectures? It's because the relative superiority among neural architectures varies depending on task and dataset. In other words, no single architecture excels in all scenarios. Then, how can you determine which architecture will perform well for a specific task and dataset? The simplest method would be to train and evaluate all architectures, which is prohibitive. As an alternative, we can utilize performance prediction, which involves accurately predicting performance rather than empirically measuring it. This approach frames performance prediction as a regression problem that estimates the performance of architectures. Specifically, we can train a performance predictor that takes a neural architecture as input and outputs the predicted performance. To be specific, first, fully train few architectures. Then, we can obtain the true performance of these architectures. Then, we can train a performance predictor using these few architecture performance pairs. After training this performance predictor, we can estimate the performance of other architectures through inference. In this work, we focus on performance predictors. Specifically, we propose a new performance predictor. Our predictor is FlowerFormer, which stands for Flow-Aware Graph Transformer. Following previous seminar studies, FlowerFormer represents input neural architectures as directed acyclic graphs, where a node represents an operation and an edge represents a data flow. More importantly, FlowerFormer is designed to capture the information flow within your architectures, including the forward pass and backpropagation, which are fundamental properties of neural architectures. To achieve this, FlowerFormer consists of two core modules. The first module is the flow encode module. The goal of the flow encode module is to capture information flow at the local level. To achieve this, the module employs message passing. However, unlike traditional message passing neural networks that perform message passing simultaneously across all node embeddings, this module updates node embeddings asynchronously in a forward-backward sequence. This method is designed to mimic the training procedure of a neural architecture and allows for a more nuanced representation of the dynamics within the architecture. The second key module is the Flow-Aware Global Attention Module. The objective of the Flow-Aware Global Attention Module is to capture global level characteristics of the neural architecture. To achieve this, the module employs a flow-based multi-head attention mechanism, which restricts the scope of attention to only those node pairs that are connected by a flow path. Next, I will discuss the experiments. For our experiments, we utilize widely recognized benchmark datasets for computer vision architectures, including NUXBench 101, 201, and 301. In addition to this, to measure performance across different domains, we also incorporated benchmarks like NUXBench Graph and NUXBench ASR. In evaluating the accuracy of our predictions for relative performance on computer vision architectures, we used the Kendall-Tau ranking metric. FlowerFormer demonstrated the best performance across all settings. In terms of performance in other domains, FlowerFormer also showed effective performance in encoding, graph neural networks, and speech recognition architectures. Finally, conclusions. The contribution of our study can be summarized as follows. First, we introduced FlowerFormer, a model designed for performance prediction that captures the key characteristic of neural architectures, that is, the information flow. Second, our model demonstrated superior performance in almost all cases compared to existing state-of-the-art models. Finally, beyond commonly used computer vision architectures, FlowerFormer also proved effective in various other domains. Here are some key references. Thank you for your attention during my presentation. For any question, please feel free to email me.